The Sieve of Eratosthenes is a very ancient and to me very interesting way of determining all the prime numbers up to a given number, n. Today I'll be showing you my implementation of the Sieve of Eratosthenes in pure C. The first thing I'll do is show how it works. We'll get all the prime numbers up to 10, and then all the prime numbers up to 100. As you can see, I've got it configured to just spit them to the command line to standard out. I'm going to run through how it works in the code. Just some boilerplate, the forward declaration for the function, a descriptive comment about the project, and some include directives for the standard libraries I needed. I was kind of bummed to include string. I didn't want to include string because I'm only using one thing from it, memset, and no, I used memcopy somewhere else. Anyways, so I'm using the form of the main function that takes the argument count and the argument vector so that we can get a number from the user and parse it. We also make absolutely sure that the number is greater than 2. So if it's less than 3, we put an error in standard error and return with a bad status code. Here we declared an integer pointer, and here I'm going to assign it the result of the function call. A bit messy in the sense that it involves itself as a parameter. I'd like to work on it still. That's where the magic happens, where most of the work is done, and the actual sieve of Eratosthenes is used, where the numbers are sifted, if you will. Then we're just going to print the elements of the array. By passing it this pointer to the number of elements, I was able to write the function such that it set that number that's being pointed to by number elements to the number of elements so that you know exactly how long the array is, so that you don't miss any of the prime numbers I gave you, and you don't start printing stuff from memory addresses you shouldn't be, risking segmentation fault. And of course, after you're done and everything's been printed, we'll leave with a good status code if nothing went wrong. Now inside the actual function itself. The first thing we do is set up a list of booleans all the way from 0 to n, which means that the numbers 0 and 1, the first two indexes, are actually wasted. Maybe I could optimize that in the near future. I use memset from string.h to set all the values to true. Initially, every number is marked as prime. And here's the actual sieve, the outer and inner loop. We start at 2, and if a number is prime, we mark all of its multiples, starting with double that number, as false. In another loop, I go back over that array of booleans and count how many are true. Store that size, and we allocate an integer array for the number of elements that we know that we have, but that we haven't added to the array yet. In our final for loop, we go through the entire Boolean array, and if an element is true, if it's prime after this sifting is completed, we add it to the array, and we return the pointer to the array. Before we wrap up, I'm going to test it some more with some different values. So we already did 10, and we already did 100. Let's try something that shouldn't work, or something too small. Let's try 1. Invalid number. And I'll try a really big value and see what happens. Looks like I got every prime number. And I can scroll up and read them if I really want to. So for 5, we get 2 and 3, our prime numbers up to but not including 5. And let's try just as a test that it doesn't include the number we gave it. It goes up to, but not including. I tested it for 31, and we got up to 29. But if I enter 35, we'll get 31 as the last prime number in the range. Thanks for watching.